Hey, it's Dave from CG Shortcuts. Today, we're going to do this. We're melting things in Houdini. This video was brought to you by Eagle, the productivity app that helps you become a happier, better designer. Eagle is an exciting new way to collect, search, and organize your image, audio, and video files in a logical way and all in one place. You can sort your entire media collection right from your desktop and search by keyword, tag, with smart folders, and even notes and annotations. Your images can then be filtered by date, rating, type, resolution, and even by color. The Eagle browser extensions also allow you to drag and drop images straight from the web, or you can batch download entire collections from your favorite sharing sites like Pinterest, Instagram, and Flickr. You can also sync your collections with your favorite cloud storage service like Google Drive, Dropbox, or OneDrive. The guys over at Eagle are offering a free 30-day trial of their app, so check out the link below and see how you can save time and streamline your digital assets with Eagle. Now let's get back to the tutorial. Okay, so welcome to our very first ever Houdini tutorial. This one was inspired by this render by Timur Salikov. So we got together with Timur and our resident Houdini expert Deneth Vihara to bring you this tutorial. Hopefully it'll be the first of many tutorials we start to cover outside of our usual Cinema 4D stuff. So let us know what you think and if you'd like to see more of this kind of thing in the comments below. So without further ado, let's hop into Houdini and see if we can create this. So let's start by creating a new project. And let's just call this something like melting. We'll also set a project path so we can keep things nice and organized. And because we're going to be caching some pretty heavy sims, we want to make sure whichever directory we choose has plenty of disk space. Okay, let's accept that. And we'll head over to our network or node editor here and hit tab on the keyboard to bring up our menu of all the different objects we can use. And we'll start off nice and simple with a geometry node. So to get that, we just need to start typing in geometry until geometry is selected. Then we can hit enter to bring that guy in. So now we can zoom in a tad by using the right mouse button, and we'll rename this and we'll call it sim because we're going to build our entire simulation inside of this. And you can kind of think of this as a folder containing our entire scene. So we'll double click on that to go inside. And now we want to bring in a mesh that we can melt. So we'll hit tab again, and this time we'll start typing file and just hit enter when that shows up. And that's going to bring in the cube geometry by default, but we want to use our own model. So we'll come up here to the file directory and click on this icon here. Then we just need to navigate to where we have our model stored on our computer. And you can use any model you like, but we're going to go with the same alligator head from Timur's render. Okay, and that's come in gigantic. So we'll hold the right mouse button and zoom out a bit. And I think we're going to need to scale and reposition our alligator head. So if we come back over here and drag this handle out, we can hit tab again and connect up another node. This time we're going to use the transform node. So we'll start typing that in, and we can also select these with our mouse. Let's just grab that guy. And then we need to activate this node by clicking right here. And now that gives us access to the transform controls over here. And we just want to move this guy above the ground plane because it needs a ground to melt onto later. So I'll just put some values in here that worked for me earlier. I'll also rotate this. And this probably all seems fairly familiar to you if you're coming from Cinema 4D or any other 3D software. And finally, I'll just scale this right down. And now we can see our alligator. So let's just go in for a closer look. You can see we've got this slightly above the ground plane here. So our melting liquid has a bit of space to fall before it collides with the ground. Okay, so here's where things start to get interesting. We're going to turn our polygon mesh into a volume and generate loads of points all over our mesh that we can feed into our melting simulation. So let's come back over here. And now that we know how to bring these nodes in, we'll add another one to the mix here after the transform node. This time we're going to use an ISO offset node. And if we activate this guy, just like that, we've turned that mesh into a volume. Although it's a little bit hard to make that out at the moment, and that's because the resolution of this is pretty low at first. So we can increase that over here under the uniform sampling. So let's bring this way up to 300 sampling divisions. And depending on your machine, this might take a little while to calculate. There we go. And now we can more clearly make out that shape of our alligator head. And you can even see the finer details like his teeth in here. And that is exactly what we want. So now we're going to generate some points on top of this volume. So back down here, we'll bring in another node at the end of our chain here. This time we want points from volume. And we'll activate that guy as well. And there's our points. But just like we had with the volume before, the resolution or the density of these points is a little bit low for what we want to do here. We can barely make out that alligator head again. So let's take a look at how many points we actually have in here. If we come back to our points from volume node and middle mouse button click here, we get a whole bunch of different stats, including the point count, which is just up here. And you can see we've only got 13,937 points being generated into our volume, but we could probably bring that up into the range of 100 to 200,000 while we're experimenting with our simulation. And we could take that even higher when we come to do our final sim. So let's go up here, and I like to make sure the source type is also set to fog, although by default it looks like it's auto-detected that anyway. Then we can increase the point count by decreasing the point separation. This basically pushes the points apart or brings them closer together. And if we decrease this, we're actually generating more points when it brings them closer to each other. So let's try a value of 0.04. And you can see we've definitely got a load more points in there now. And we could even go and see exactly how many points we've got. And we're now on well over 230,000. So we'll work with this for now and increase this again later for our final sim. So we can probably start simulating this now, and we're going to do that by bringing in yet another node. This time we want a POP network, which is short for Particle Operator Network. And I know that sounds kind of scary, but it's actually just Houdini's particle solver. And this is a DOP or dynamic operator, which we're going to use to turn these points we've generated into dynamic particles. So we'll activate that and go inside here. And you'll notice our points have gone blue now. But this is actually just a guide to show us what we've applied this to. So if we click here on the source, we can come up here and disable that. But now we've lost our alligator completely. And even if we play our timeline through, we still have nothing. So where did our particles go? If we look up here under the particle emission type, we can see we're currently set to scatter on surfaces, but we don't actually have any surfaces to scatter onto because we turned our mesh into a volume. So let's see what other options we have in here. Let's try changing this to all geometry. And now we've got our particles back. So if you remember from our final render, we had our alligator melting from random places across the surface of the geometry. So the next step is to tell our simulation where the melting needs to take place or start from before the melted liquid falls to the ground. So we're going to go back a level to our sim, and we're going to add another POP network from our transform node here. So we'll drag this out and bring in one of those. And we're going to scatter some more random particles over our alligator, which will tell our sim where to melt from. So let's rename this guy. We'll call that scatter, and we'll activate that and go inside. And again, we'll disable our guides. And you can see we've already got a bunch of random particles being generated on here. So if we were to hit play and just make sure our playback is set to real time, we can see more particles being emitted over time, which is exactly what we want. But we do only want the melting to start from a few places on the model and not all over it like it is now. So let's bring the amount of particles down, and we'll head over to the particle source, and we can decrease the amount of particles being generated up here with the birth rate, just like we would in Cinema 4D. So we'll bring this guy down to 15 and give that a try. All right, so our melting is going to happen from just these points. So let's set that up. Let's go back a level here. And we can keep our node graphs nice and tidy by hitting Shift S on the keyboard. And that just cleans up our connection lines here, which can be pretty handy as things get more complicated. Now we're going to add some spherical fall off to our particles so our melting looks a bit more organic. So we'll bring in a sphere. And to attach this guy to all of our points, we'll also bring in a copy to points node. And we'll just put that guy down here, and we'll plug our sphere into the first input here and our scatter into the second input. And we need to activate our copy to points node. And now we can see our sphere. And if we hit play, we've now attached a sphere to each one of those particles that are being generated over our mesh. But they're just popping in there at the moment. We actually want our spheres to grow over time after they've been emitted, so our melting is nice and organic. So let's rewind this, and we can probably bring the size of our spheres down first. Let's make the scale 0.6. And now things are going to start getting a bit more advanced. We're going to use an expression to give us the particle life and use that data to drive the scale. So we'll bring in a node called point wrangle, and we'll connect that guy in between our scatter and our copy to points node. And so we don't get confused, let's name this guy calc life, because it's going to be calculating the life of the particles. And we can put our expression up here, which is actually called a vexpression in Houdini. But to do that, we need to figure out which attributes we need to target in our expression. And each node has a bunch of attributes, which we can access by hovering over one and clicking the middle mouse button. And here's a list of attributes available in our scatter node. So the two attributes we're most concerned with are the age attribute and the life attribute. So let's come up here and we'll create a custom attribute. And when making custom attributes, we just want to make sure we're naming it differently to the attributes that are already available. So we want to give it a pretty unique name. So let's first type the @ symbol, which is used for attributes, and we'll call our custom attribute calc life. And this attribute will equal @age, which references the age attribute, divided by @life, which is the life attribute. Then we just need to put a semicolon at the end to indicate the end of our expression here. And now we want this expression to drive the scale of our spheres. So we'll bring in a second point wrangle and put that guy in after our life calculation. And we'll rename this to scale driver. And we'll give this guy a custom attribute as well. And we'll call it a new scale or new scl.equals. And we're going to use a ramp attribute to ramp this up with time. So that attribute already exists, and it's actually called chramp, which I think is for channel ramp. Then we need to add brackets and quotations. Then we'll type our call out here, which will be ramp, then a comma, and we'll reference our custom calclife attribute and end this again with a semicolon. And then we need the attribute that's controlling the scale of our spheres, which is @p_scale equals our custom attribute @new scl or new scale. And we've actually forgot to add the @ symbol before this attribute, so we'll put that in there. And we'll finish this off with another semicolon. And now if we click outside this window, you'll notice everything disappears. And that's just because we need to set up our ramp. So we actually need to click this button to run our code and generate our ramp controls. And now if we scroll down, here they are. And we can adjust this just like we would in Cinema 4D. We can add some points to adjust the shape of the ramp. And if we hit play now, we'll see those spheres are starting to ramp up in scale as time goes by. Okay, so we're about halfway there now. So let's just organize things over here. We can put this stuff into a null. Let's drag out from here and we'll add a null, which is a bit of a different looking node to the others. Let's just activate that and rename it. Let's call it trigger, because we're going to use this setup to trigger our simulation. Then we'll grab our pop network over here and we can rename this to sim, because this is our simulation. And we'll go inside there And we can tidy up the connections again by hitting Shift S. And we'll just make a bit of space in here. And we'll bring in a pop group node. And we'll put that guy right here after the source node. And we're going to use the pop group to group all of the particles that find themselves within our spheres. So first, we'll name our group, and you can call it whatever you want, just don't use spaces. So to keep it nice and simple, I'll just name it capital N. And then we want to bind this to the shape of our spheres. So we'll head over to the bounding tab and enable that. Then we don't want this bound by a box. We want to use the geometry of our spheres. So we'll choose bounding object. And just like we're used to with our cloners in Cinema 4D, we just need to tell it which object to use. And we want a SOP object. And we can actually choose from a list of what's actually available in our scene over here. And here's that trigger null we created before with all the elements of our growing spheres. So we'll use that as the object. And you can see that path has been edited in there now. And if we hit play, it can be a little slow to calculate, but any particles that are within our growing spheres will now become part of our pop group. So now we want to tell our particle system to only affect the selected particles in our group. So as our spheres grow, any particle they touch will have physics applied to them. So we need to add another expression in here to do that. But first, let's bring in another pop wrangle node. And as we get more complicated here and add more nodes, it's always a good idea to rewind the timeline and reset everything. Otherwise, we might end up crashing things. Now let's grab our pop wrangle and we'll enable the group option here. Then we can tell this to look at the group we just made, which is called N. And this way, our expression will only be applied to that particular group and not the other particles in our scene. And we need to write an expression that basically says any particle that joins the group as the spheres grow will also initialize the simulation. So we'll type in I for initialize, and we want it to initialize when it becomes part of the group. So we'll say initialize at the state of being included in the group. So we'll type state equals 1, so it becomes part of the group. And now that those particles can initialize the sim, we also want them to act like fluid when they become initialized. So we need to add another particle stream to apply the fluid effect to. So let's drag out another connection from here and bring in a pop stream. And so we want the initialized data to carry into this as well. So we'll change the expression here. When our group equals initialized state of 1 or on, it'll also be active in this stream. And now we can add our fluid effect. So we need to bring in a pop fluid node. And then we can get our fluid simulation parameters. So let's go through some of these. Firstly, we've got the particle separation, which does kind of the same thing as before. The smaller the number here, the more particles and more detailed our fluid is going to be. So let's add a bit more detail to this and bring this down to 0.05. And then we've got the iterations. Bringing this up will give us a more accurate sim. So let's make that 30. Then we've got the constraint stiffness, which is how close our melting particles stay to each other. Higher values will stop particles breaking away. So let's bring this up to 100. Then we'll bring the tensile strength up slightly to 0.005. And the viscosity up to 0.3, so our liquid isn't too runny. And now we need to add some gravity in here to pull our liquid down to the ground. So let's bring in a pop force node. And we want our force to be pulling down in the Y direction. So let's make that a value of something like -6. Okay, let's try playing that back. And it doesn't seem like anything's happening. And I think that's because we need to go back to the pop source. And let's just rewind this so we don't get any crashing. Then we'll head over to the birth tab and make sure this is activating on frame 1. So we'll type $FF for frame equals frame 1. And before we try and play that back again, we can make this a bit easier to visualize. Let's bring in a pop color node and connect it to the end of this node stream. And we can change the color of this by clicking here. Let's just make it black and close that. Then we can add another color into the second stream here. And we'll make that one white. Okay, you can hit the L key to auto-arrange these nodes so they're nice and tidy. And there's one last step. Let's merge in a ground plane for our liquid to melt onto. So right down here at the end of our node stream, we'll add in a merge node. Then over here, we can bring in a ground plane node. And we want to tell our simulation it needs to collide with this. So we'll also connect up a static solver, which is kind of like a rigid body in Cinema 4D. And we need to connect that to our merge node as well. And if we take a look at that guy, we need to make sure our static solver comes first in the calculation. So let's just bring that up above the pop solver. And now if we hit play, we can finally start to see that melting effect. And the speed of this sim will depend on the power of your machine. If you find it's really slow, just bring your particle count back down a bit. So the white particles are the melting particles and the black ones are the static particles. And if we zoom in, you can see as the white ones melt away, it's corroding our alligator mesh. So we're now ready to increase the number of particles and cache out our final high resolution simulation. But before we do that, let's rewind again so we can avoid any crashes. Then we can go back a level to our sim and we'll head back to our points from volume. And to bring in more particles, we just need to decrease the point separation. And the smaller you make this, the higher resolution our liquid will be, but the slower the simulation is going to be. So let's try 0.02. And now our particles are quite a bit more dense. And we could middle mouse click here to see the exact particle count, which is now 1.9 million particles, which is pretty big. So you're probably going to need a decent computer with plenty of RAM to be able to handle this simulation. Hopefully we'll be okay. But before we do this, we could also increase the resolution of our pop fluid. So back in our DOP network, we'll grab our pop fluid and we'll decrease the particle separation here as well. Let's try 0.02. And now we're finally ready to cache this. So we'll come down here to the output node and we'll save this to disk. And the caching might take a while, so go and grab a coffee or something. We'll just edit that bit out and be right back. Okay, so we're back, all cached up. So let's go back here and click on our DOP network. And you can see we have this little playback simulation option up here. So let's tick that and it should automatically load our cache simulation into here. If not, just click here and find your cache on your computer and just bring it in. So now if we hit play, you'll start to see our timeline turning purple instead of blue. And that just indicates that we're playing back a cache now. And there is our melting effect. And that pretty much brings us to the end of the particle setup. But to render this out, we need to turn our particles into a mesh surface that we can add materials to and all of that sort of thing. So we'll come back to our DOP network here and drag out a new connection. And this time we'll bring in a particle fluid surface. And we'll grab that guy and activate it. And straight away, that gives us a nice mesh surface over our particle sim. But the resolution of that mesh is pretty low by default. We will need to add a bit more resolution in there if we want to capture all that detail. So if we take a look up here, this option should be pretty familiar. Just like we did with our particles, if we bring the particle separation down, maybe to a value of 0.03, we'll subdivide that mesh. And now you can see all that nice melty detail in there. And finally, we just want to separate the melted parts from the base mesh so we can texture them individually. So back down here, we'll bring in another node. This time we're after the attribute transfer. So we'll bring that in. And if we connect our particle surface into the first slot here and the sim DOP network into the second slot, that will separate those out for us. So now we just need to cache this bit out as well before we render it off. So we'll bring in one final node. We want the file cache node this time. and we'll save that to disk as well. And again, that should appear here as soon as that's done. Otherwise, just find it on your computer and load it up. It did take quite a while to cache out, so I've done that in advance to speed things up here. So we'll just link this up to where I've cached it out on the computer. And we don't want to forget to check the load from disk box. And now if we scrub through the timeline, it should be nice and fast, but it's not. And I think that's because we're seeing the attribute transfer node because we forgot to activate the cache node. So if we do that, it should read directly from the cache and be a bit faster on our timeline. And there we go. That brings us to the end of this tutorial. Definitely one of our longest shoots, but Houdini is definitely a bit more complicated than Cinema 4D. But hopefully this will give you an idea of how powerful the procedural workflow can be in Houdini. As usual, you can download the project file below to save a bit of time. And if you found this useful and you think we should do more Houdini tutorials, just let us know in the comments. Okay, that's it for this week. Catch you next time. Thanks for watching. Let me know what you want to see in the comment section down below, or you can leave a like or dislike. And don't forget to subscribe and click on that little bell icon for more videos and free stuff. There's loads of extra resources on our website, and you can win epic CG prizes in our monthly challenges. Check out cgshortcuts.com for more details. Catch you next time.